Select the major product of the following series of reactions. So we can see that we are starting with a secondary alcohol. And the first thing that we are doing is we're treating this with thionyl chloride and pyridine. So these are conditions, as we've seen in a previous video, to take an alcohol to an alkyl chloride, and it's overall an SN2 substitution. So that means that when we do this, the step where the chloride adds is SN2. So when we do this, we should expect to see that the chirality at this center is going to invert as a result of this SN2 reaction that takes this from an alcohol to an alkyl chloride. And so now we've got a secondary alkyl halide. And now we're taking it through the second set of conditions. So we've got potassium tert-butoxide and heat. So we want to be able to interpret this and know what this structure is. So when you see potassium or sodium attached to something, those are alkali metals. So that means that it's just going to be a counter ion. So this is potassium plus. So we don't expect that potassium ion to be involved. What it's attached to, though, most certainly will be. And so here is that tert-butoxide. So an oxygen, I'm going to spread this out so we can take a look at the structure and decide what it is, right? Oxygen bound to carbon, and that oxygen has a negative charge, which we know because it's attached to potassium, which is positive. And then this carbon has a lot of branching. It's got 3 methyl groups attached to it. So what this is a strong and large bulky base. So the combination of a secondary alkyl halide, a strong bulky base, this is going to be an E2 reaction, and specifically it's going to give you the less substituted alkene, and that's a result of this being a bulky base. So being really large, it can't squeeze in to these more hindered hydrogens, which it would prefer to do to give you the most stable alkene. It's instead going to take one of these terminal hydrogens simply because they are more accessible. It's easier to reach one of those hydrogens. And so what this is going to do is it's going to form the alkene terminal at the end of the chain. All right, and that's the result of this bulky base doing that E2 reaction. And so we can see that that is option D.